In this tutorial, we'll be looking at the sample mod again, this time paying particular attention to the structure of a tractor's XML file. We'll start with the wheels of the tractor. These are set here. The auto rotate back speed attribute determines how fast the wheel turns back to the center when the control keys are released while driving. This is then followed by a list of the wheels. Each wheel must have the attribute wrapper. This index path sets where the wheel should be located. If we look at the first wheel, we see the index path 0 greater than 0 for wrapper. In the Giants editor, we can see that this corresponds to the front right wheel. This wheel has a separate mud guard, which should rotate around the y-axis when you steer, but shouldn't move in or against the direction of travel, meaning it should not rotate around its x-axis as well. Therefore, the wheel is a child of the mud guard and is defined in the XML file with the attribute drive node. This ensures the two rotations are split up, with the mud guard only rotating around its y-axis, while the tire rotates around the x-axis. If we don't define the drive node attribute, then the wrapper object will be rotated around both axes accordingly. The attributes rotmax and rotmin define the maximum and minimum steering angles respectively, while the attribute rotspeed sets the speed of this rotation. If the value of the rotation speed is negative, the wheel will rotate in the opposite direction instead. This is useful for rear wheels that can be steered. The radius value specifies the radius of the wheel and should match the radius of the wheel we can see in the game. The susp travel attribute sets the length of the spring on which the wheel is suspended. The spring force and the internal friction of the spring will then be specified with the spring and damper values. The spring usually starts at the 0 point of the wrapper object in the i3D file and points vertically downwards. This then shifts the wheel slightly downwards. We can counter this problem by pushing the starting point of the spring up slightly. This shift can be used to determine the attribute delta y. As a general guide, this can be set to a value of approximately half the susp travel value. An alternative is the initial compression parameter, which we typically set to a value of 0.5. This then indicates that delta y should be set to a value of half the susp travel value. The values max long stiffness, max lat stiffness, and max lat stiffness load determine the characteristics of the frictional force acting on a particular wheel for the longitudinal and transverse directions separately. It must be noted, though, that max lat stiffness load does not specify the maximum frictional force, but instead sets the weight at which the lateral friction force reaches its maximum value. The value for mass specifies the mass of the wheel in tons. With the entries for the differentials, we can set the properties of the power transmission from the engine to the tires. A differential entry defines either the ratios between the two wheels on an axle or the ratio between two axles. A value of 0 for torque ratio would mean that all the power is going to the first element, to wheel index 1 or differential index 1. The value for max speed ratio indicates the maximum percentage by which one element may move faster than another. With the motor node, we can set the engine values, defining the maximum speed and the tractive force. The values min forward gear ratio and max forward gear ratio determine the transmission from the engine to the wheels when in a forward gear. The respective values for min backward gear ratio and max backward gear ratio are set for the reverse gear. The smaller these values are, the faster the wheels will rotate to maintain a constant engine speed. Max forward gear ratio then corresponds to the first gear and min forward gear ratio to the highest gear. The max RPM attribute determines the maximum revolutions per minute of the engine. The min RPM attribute, however, determines the level of the idle mixture. Below these are the entries for defining the torque curve. These entries are normalized into one factor, which makes it easier to transfer the same behavior from one tractor to another. Then, to give the tractor more or less power, we use the torque scale entry. To easily adjust the values for the transmission, we can open the Vehicle Motor Calculator XLS file found in the SDK subfolder of the Farming Simulator installation directory. We then simply enter the desired data in the two left columns. In our case, these are 34 for the maximum speed and 2250 for the maximum rotational speed of the motor. We now get the result we need, the value for the gear ratio, on the right. We then take this value and paste it into min forward gear ratio. The tractor will then drive at a maximum speed of 34 km/h, provided it has enough power to move itself and any attached devices. Before we look at the other entries in the XML file, we should point out that there are two extremely useful commands in the console of Farming Simulator 2015, which we already got to know in chapter 26. With GS Vehicle Reload from XML and GS Clean i3D Cache, we can make changes to the XML and i3D files of the vehicles respectively, and reload them without having to restart Farming Simulator. Now let's get back to the entries in the tractor's XML file. Fuel capacity determines how many liters the tractor's tank can hold, and fuel usage is the consumption in liters, which depends on how much power the tractor is currently using. This is where the cameras are defined. The number of cameras is determined by the count value. For each camera, the index path is used to set the index attributes of the camera's object in the i3D file. If the camera isn't to be rotated around itself, the point of rotation can be determined with the attribute rotate node. For this, the camera must be a child, a sub-object of the rotation point. The external camera tries to avoid other objects. To do this, it checks whether the vehicle is visible from the desired camera position, and if not, moves the camera closer to the vehicle. To be able to check this, particular points on the vehicle are used. These points can be defined with the attribute index of the raycast node. Usually these points are found at the front and rear end of the vehicle at the top edge. The lights are defined here. There are three different display types of lights: real lights, fake lights, and decoration lights. For performance reasons, not many real lights can be displayed. That's why there are fake lights, which are displayed if the AI is driving or a multiplayer teammate has turned on the light. Decorations are always displayed when lights are turned on. This can be used to represent a corona effect, for example. Furthermore, each light has a light type associated with it. By repeatedly pressing the light button in the game, we can scroll through the different types of light. With the first click, we activate light type 0. With the second click, we activate both light type 0 and light type 1. With the third click, we activate light type 0 and light type 2, and so on. As a rule, the normal front light should be light type 0, the rear working light should be light type 1, the front working light should be light type 2, and the other working lights found on vehicles, such as by the combine harvester's unloading auger, should be light type 3. With the GPU's profile set to high and very high, a maximum of 2 real lights are used, whereas low and medium settings use only 1. If more lights are active than can be displayed, the order of lights in the XML file determines which lights are displayed. The further down a light is, the higher its priority. Thus, in our sample mod, only the working light of the Burer 6135 will appear when using the low settings, if both the front light and working light are active. Then we see the entries for the brake lights and the turn signals here. Then here we have the entries for rotating beacons. If we look at the corresponding node in the Giants editor, we see that there's no real rotating beacon setting, only a transform group. So we won't need to integrate our rotating beacon directly into the vehicle, and will instead use a transform group at the point at which you want a rotating beacon to appear later, entering the necessary information into the XML file. That is, as we've already shown, the index path to the transform group at which the rotating beacon is to be positioned, the speed at which to rotate the rotating beacon, as well as the path of the rotating beacon which is to be loaded. Altogether, a total of 5 different types are available. Here we can define the steering wheel. The index attribute determines the object in the i3D file, and rotation speed sets the speed at which the steering wheel is rotated. The player's location when exiting the vehicle is set with the exit point value. The element motor sound lets us set the sound of the engines. For this, an audio file is defined, which will then be played back repeatedly. And depending on the engine speed, the pitch will be adjusted. At 0 speed, the pitch is set with a value pitch offset. A value of 1 corresponds to the original pitch as in the audio file. Possible values range between 0.5 and 2. The pitch scale value specifies the degree of the change. This is multiplied by the engine speed and revolutions per second and added to the basic pitch. As an example, in our XML file, the engine reaches a maximum speed of 2,250 revolutions per minute, which corresponds to 37.5 revolutions per second. At maximum speed, the pitch is then 1 plus 37.5 times 0.02, which equals 1.75. However, we also have the option of limiting the maximum pitch, so that even at less than the maximum speed, the maximum pitch is still reached. This can be done with the pitch max attribute. In the case of vehicles that one isn't steering oneself, a sound is played outside the vehicle, which takes into account the three-dimensional positions of the player and the vehicle. The maximum range of this sound source is specified with a radius attribute. In addition, the attribute inner radius can be used to set the maximum distance at which the sound can be heard at full volume. From this distance on, the sound will become increasingly quiet until it completely disappears at the specified maximum distance.